Stephanie's online now. All right. Okay, is that everyone? No Lewis then. All right, well. Are you ready? Are you ready? Then let's begin. Good morning, everybody. What? What? Conversation's over. It's time to do math. All right, well, good news and bad news. Good news, I got the speaker working at least, so I have sound in the room again. Which is great, because now I can play music, I can hear you guys over the Zoom call and everything. However, what I've done is I've directly connected via Bluetooth straight to the speaker, completely bypassing the projector process, so I still don't have a screen for you guys in class. So if you want to see what I'm doing, and I recommend, because today is a very visual day, you go ahead and join the Zoom call as well. I didn't do it. You blame the computer, okay? It's his fault. It worked just fine until suddenly last week it didn't, all right? Been working on it. Anyways, so today we get to do something pretty cool. Today we get to actually graph some rational functions, all right? I think it works. Okay. So before we do that, real quick, let's go over answers from yesterday. So here we have, remember the first 6 were just asking for the excluded values. Which values can we not let the variable be equal to, because then we would be dividing by 0. So there are the first 6. And then from 7 on, you had to also simplify the expression as well as solve the denominator for zeros. So stop me at any point. I'm just going to scroll through slowly. Okay. I like number 14. It's just kind of goofy in its simplicity. It's the same exact thing on top and bottom. It's a really fancy form of 1. More like 14. Put 14 on the test. All right, and Where's the last ones? Scoot it over a little bit so you can see the rest of my work there on 24. All right. Any questions from this sheet? No? Online? You know, they did use it for announcements. We might get back to that again. Oh, all right. Then let's draw. Graphing rational functions. Okay. What we're going to do today is we are going to practice the actual graphing part straight from given features of the graph. So you can see in our practice today for these 6, what I have done is instead of giving you an actual function, an equation, I've given you, hey, it has an intercept here, it's got an asymptote there, and you're going to use those features to create your graph. Okay? What? Yeah, we're going to draw it. By hand, yes. So, well, there's a couple of reasons we want to draw them by hand. One is because it's fun, okay? These are really neat-looking graphs, okay? 2, it's actually pretty easy. When you get the hang of it, you can whip up a quick sketch to get an idea. It's not a perfect, exact graph. You're not going to use it to analyze and try to compute some further value out of it. But if you just want to get an idea of what it should look like in your head, you can quickly sketch these out much faster than it would be to type the whole thing into the calculator and work that way. So if all you need is the picture, you can come up with a quick sketch pretty easily. There's just a few key principles here, right? Intercepts and asymptotes, okay? And if you keep in mind that all of the listed intercepts are the only acceptable intercepts, and all of the asymptotes cannot be crossed, okay? Those rules will let us force the graph. It has to go a certain way based on the given information. All right? Okay, so the best way to see this is by doing it. So let's take a look at number 1. We have a y-intercept of -1, no x-intercepts. That means my graph is not allowed to cross the x-axis at any point. I have a horizontal asymptote at y equals 0, and a vertical asymptote at -2 and +2.
So I like this on -2 and 2. 2 lines.
Vertical asymptote. Vertical.
Vertical, yeah.
You said like this. This is the horizon.
Oh, like this.
This is horizontal. Vertical, touchdown. Okay? So, whip up a quick set of axes to start with. Here's an x-axis. I'm going to give myself lots of room. And I'm going to put my y-axis somewhere in the middle because I have a negative and a positive. We want to show both types of values here. All right. And then I need the 3 numbers on here, right? We are given -1, -2, and +2. So make sure those are clearly visible on your graph. So y is probably just going to be 1, 2, -1, -2. X will go out a little bit farther. You always want to go out a little bit farther on your X, just so that you can see the end behavior, right? We want to be able to tell what this graph does as X is going to get approaching positive and negative infinity. Vertical asymptotes are pretty clear in a small amount of space, right? They're very steep turns. But the horizontal, you want to make sure you have enough of a widescreen view to see what happens at the end there. Fernando, now is not the time. All right, so what would you like to tackle first, intercepts or asymptotes? Asymptotes? I like doing asymptotes first too. So let's do that. Everywhere there is an asymptote, I want you to draw a dashed line. So a horizontal asymptote at y equals 0. That's straight across the x-axis. Yes, it's going to look a little bit redundant since I already have a line there, especially if you're not using multiple colors. But please start with that as your habit, just to remind yourself, oh yeah, don't cross that ever again. And then we need another one at -2 and +2, so it'll be a vertical dashed line. No, not zoom out. Draw for me. Thank you. All right, there is the structure. And really quickly, don't follow me here. I want you to understand what this thing could look like, right? It could be something like that. It could be something like that. They could all be on the same side. Of course, this could be bottom, up, bottom, right? Something like that. You're going to create these loops and curves. Remember that you approach and hug the asymptote without crossing it. So, all 6 at once, and then fail the vertical line test everywhere? That's probably a bad idea. So no, it cannot fill all 6. Remember, it still has to be a function, so it has to pass the vertical line test. So if you think of this in sort of 3 sections, right? I can only have a graph in one of each. So the top or the bottom, top or bottom, top or bottom for each one. Now, how do we determine where it has to go, which side it has to be on? That's going to come from our intercepts. So we know there's a y-intercept of -1. My graph has to go through that point. Okay? If it was up here and was coming from this intercept, and it would have to like dip down and touch that and then come back through, that can't happen. I crossed the x-axis. That's no good. So this clearly must be down here, and so we get kind of a U shape from there. Okay? And you can also go from the intercept if you want to go like this and out and extend towards each. And then imagine driving your car, and then all of a sudden there's a wall there. Oh shoot, I better start turning, right? That's what happens when the graph approaches an asymptote. It's got to turn away from it so you don't crash. Now, because I've got that up there, just a quick reminder, I can have no graph up here. Otherwise, I'd fail the vertical line test. So now we got to determine the ends. Right? Are they up here like this, or are they down here like that? You think they're up? Why? Oh, could one be up and one be down? Could be. That's also plausible. We don't quite have enough information here. Right? This one's been left vague. It doesn't specify. So the default is to always switch. When you come to a vertical asymptote, you are almost always going to switch signs. So since this was negative down here, it's going to swap to be the positive side over there. That's what most often occurs, okay? Unless the function has some feature that would cause it to be both in the same direction, and that's usually a squared term, okay? If it was like a double. So just real quick, on a side here, the function 1 over x looks like that, right? It splits. It's got one side positive, one side negative. 1 over x squared, though, is the volcano guy. It's got both on the same side. Okay? So when one of your asymptotes is the result of a squared term, that's when you get the double up on the same side. Okay? So since we are not told that that happens on this function, we're not given that as one of our features, we're going to assume it didn't occur and the default to swapping sides there. Again, technically if you drew the other way, it wouldn't conflict with any of our given features. But this is the most likely based on what's given. Does that make sense? Okay. Then let's do one more together, and I'll leave the rest to you. Which one would you like? Have them stand out to you. Read through each of them. Show us one with opposite sides. Perla, what do you mean by opposite sides? Or is that too old of a question now? Amy's voting for number 5. What's that? Your pick. And we got 1 vote for 4, 1 vote for 5. Like 1 on the negative and 1 on the positive. That's what we had here. This was 1 on the negative, 1 on the positive. I don't understand what Perla's getting at here. 5 has the slant. Slant asymptote, so instead of my horizontal one, you're going to draw literally a sloped line and treat that the same as you would a horizontal asymptote. Side of the graph, the outside arrows. One positive, 1 negative. Referring to the ends here, the endpoints. Yes. Okay. You can only have one side or the other. I can't put another one down here because then it would fail the vertical line test. All right? Yeah? That's what we have. Like, look at half of this graph. That is that shape. Right? Okay. All right, so far I've gotten more votes for 4, so let's look at 4. And then maybe if we have time, I'll briefly talk about 5. Okay, what do we got going on 4? Negative y-intercept. Okay, so we're not given a specific number. Horizontal asymptote on the x-axis. So same as before, it's going to be at y equals 0. Vertical asymptotes at -2, -1, and zeros at -3 and 2. Oh, so now we do cross at those points, okay? This will be more interesting then. So let's get some axes up. There's X. There's Y. I need to mark off, let's see, Y can be whatever I want, positive 1, negative 1, because I don't have any numbers in that direction. I need to go to at least to 3. So we're going to maybe 2 more beyond that, just so I can see what the end behavior looks like. So here's negative 3, positive 3, and 1 and negative 1. All right, my asymptotes are at negative 2, so go back to negative 2, vertical line here, and positive 1, line there, and horizontal on the x-axis. Now, I said you're never allowed to cross an asymptote. That's not entirely true. The horizontal asymptote is your only source of exceptions. But you can only cross it at the indicated points. So I'm told it crosses at these points and no others. Okay? But the end behavior is going to, when it can, the function will tend back towards the asymptote. It's almost like they're magnetic. It just kind of draws things into it. So we have a 0 here at negative 3 and positive 2. We have to cross there. I'll put that in blue instead because that will be part of our graph. And we have a negative y-intercept. Put it something like that. The actual number doesn't matter. We weren't given one. Okay? So in fact, if we really want to be accurate, maybe we just don't even label the y-axis. We'll leave that up for interpretation. It could be 5, could be 10, who knows. But that is enough to tell us, just like number 1, we have to have this loop go down here. Right? Because it has to cross the y-axis in the negatives. If I had a positive y-intercept, I would put it up here. So we can start with that. That's usually your best starting point. Go with that y-intercept when given or calculated. And if you have a function, it's very easy to calculate. You just plug in 0 for x, whatever number comes out, right? The easiest point to find on any graph. And now we're going to use that same rule. When you flip over a asymptote, we're going to switch the signs. So over here, I went towards the negative. So let's start at the top up here. And, oh, wait. I can't just do that because I need to cross through here. Okay, so let's still follow the asymptote, but let's actually cross through it. And where does it go from here? Where can it go? It has to follow and turn back towards an asymptote somewhere, right? We're not given a slant asymptote. It doesn't take off at an angle. It can't turn around and come back down here because then we're failing the vertical line test, okay? We can't turn around and go back. We have to keep moving towards positive x. So the only thing we can do is turn back up here and approach that asymptote. Well, we can't cross again. We had to come down once at this crossing, and then we have to return to the asymptote. So we come back, kind of, imagine driving a car. You got some momentum there, right? We can't immediately stop, make a sharp turn, and jump back. So we turn around quick as we can, and then resume along that road. And then it can't cross the red lines at all. And we've got the same thing happening on this side. We started at the bottom, so we're going to come from the top of the asymptote here. We have to keep coming through to cross at that -3 and loop up and resume along our asymptote there. It's a funky kind of effect. Back to the, correct. Because remember, it still has to be a function. It cannot fail the vertical line test. So don't ever reverse direction left and right. Can't turn around and go back that way. So since we're heading off to the left here, we have to continue always heading towards the left. We can never cross the red lines except at the given zeros, the x-intercepts. Those are like the only gates through the wall that we're allowed to use. All right? Yeah, 5 isn't actually that bad. Again, your slant asymptote takes the place of your horizontal asymptote. Right, so you've got a vertical asymptote at 1 and a slant asymptote with a low slope and a low positive y-intercept. So I would go, something like that, except not quite as sloppy. Well, this is the beauty of drawing your own axes. If you wait until after you draw the line, I can go back in and I can say, yeah, that's supposed to be 0.5, right? Don't set yourself up for a hard time here. Make it easy. Draw your line first, then decide, then label it. That's 0.5 right there. See? 0.5. It is because I said so. Someone coming along after to look at your work, they don't know what order you drew things in. What? Hold that thought. Any questions on this process? I'll answer that in a minute. Start with math questions. No? You're good? All right, excellent. Because then the next thing, not today, I guess not tomorrow, right? Thursday, right? When you're back. Next thing will be then from a given function, how to determine all of these traits just from looking at that equation, and then we can turn those traits into a graph. Nice? All right. Okay. To answer your question, Fernando, I went to the University of Notre Dame. Yeah. Physics.